Good morning, afternoon, evening, whatever time you're watching this class. This little micro lecture, which is just a little short. It's not even a lecture. It's more just going over some examples and trying to help clarify the difference between general motion, rotational motion, and linear motion. Okay. And so what I thought I'd do is use some playground equipment, things we're familiar with, right? Uh, Many a fun time spent on the old merry-go-round. So the merry-go-round, without anyone on it, would be an example of rotational motion, right? In other words, is it moving? Yes. But is it going anywhere? No. The center of mass, the representation of that object, the center of mass, isn't going up, down, left, right, front, back. It's staying put. So when you rotate the merry-go-round, it is moving, yes, but it isn't going anywhere. It's moving because it's rotating. It has rotation. But because it's not translating up, down, left, right, front, back, then it doesn't have general motion, right? It doesn't have that combinational thing. So this would be an example in the playground of pure rotation. Now, what happens if kids get on the merry-go-round? Well, kids would redistribute the mass. That's why you try to get one kid on one side, another kid on the other side to try to keep it as pure as possible. But if you have just one kid on the merry-go-round, you're going to notice how the merry-go-round's probably going to wobble. It's mostly rotation, but now you have an element of redistributing the mass because now the center of mass of that system is not exactly in the middle. It's going to shift a little bit to the kid. So the center of mass of that system is actually going to wobble around, okay? But an empty merry-go-round, mostly pure rotation. Let's see what's the next. All right. There's another cool thing on the playground, right? Some little high bars that you can swing from if you want. This picture, though, was meant to illustrate pure translation. If a kid is hanging from the bar, maybe you're doing a test, a time test to see how long they can hang. Or maybe they're doing a contest to see who can hang the longest, okay? It's fun. You just hop on and you can swing or you can just hang. If the kid lets go and falls down to earth, right? That's pure translation. The kid, represented ever so masterfully by this marker, the kid, when he falls down, isn't going to do double, triple flippy things, right? He's just going to go straight down. His center of mass is going to go down. Is he moving? Yes. Is he going somewhere? Yes. He's going straight down. Okay? Translation. All right? Straight line motion. He just goes down. Now, the opposite of that, I say the opposite. Brian. Okay? So, someone who's maybe swinging, right? As you swing, let me get a more better example of a swing. There we go, to avoid confusion. So, someone who's swinging, this would be a good example on the playground of general motion, a combination of translation and rotation. Are they moving? Yes. Are they going anywhere? Yeah. In fact, this little girl here, if she didn't rotate, she would go down and she would go up and she would go back. But we know that she's going to have some rotation. She's going to rotate as she goes down, up and back, and it's going to happen simultaneously with the translation. So in essence, she goes from here to there. Here's the translation. Obviously, I didn't curve it. I just showed you what's going to happen. And then here's the rotation. And that's all going to happen at the same time. So swinging on a swing would be an example of general motion, a combination of rotation and translation. Cool. A lot of our movements are combination of translations and rotations. So what I want you to imagine is if this girl's swinging like this, okay, swinging, general motion, the center of mass of the system is here. It's going to go down and then back and then up and then down and then front. This swing is very similar to how a shoulder swings, how a shoulder works. Okay. Let's say I had a weight in my hand and that represents the mass of the girl. And she swings back and she swings forward and she swings back and she swings forward. So is it rotation? Some of it's rotation. We rotate our shoulders and the shoulder is a joint. But I have to get you guys to see that there's also some translation there as well. The mass of my arm, especially with that weight in the hand. That was actually a 75-pound weight. The weight of my arm also translates. It goes down and back, and then up and back, and then down and forward, and then up and forward. So there is an element of spin, but there's also an element of translation. And those are terms when we're talking about joint motion. That's going to be the flexions, the extensions, the abductions, the adductions. We give those terms from the perspective of their spin. What I mean by that is we can't talk about shoulder motion just in terms of translation because the translation changes. Down and back, and then up and back. But what doesn't change is the direction of spin. The rotation component doesn't change in joint motions, but the linear component can change. Up and back. Whoa, if I keep going down and back. But what doesn't change is this is clockwise, counterclockwise. Obviously, it depends on how you're looking at this. The rotation doesn't change. The spin is constant. The translation changes. Okay, it's like going around a track. Like if there was a track on the outside of this playground, right? And you would go around the track, your linear motion would change. Sometimes you'd be going east, sometimes you'd be going west, north, south, but the rotational motion wouldn't change. So we tend to name things in our body's joints for the rotation, even though there's some translatory motion there as well, okay? Another thing I want to hit upon is when you have motions in the human body that more that resemble more pure rotation, it's going to have the R word, the rotation word in it. So in other words, when we get to the cervical vertebra, I'm just using this as an example, you're going to have flexion, extension. That's general motion. The mass of my head is going forward and down, and then up and back. And obviously there's a component of spin as well. But when I look to my right or look to my left, that's kind of like spinning a basketball. That's kind of like spinning a merry-go-round. It's a lot more pure rotation. So I'm going to have terms like right transverse cervical rotation, left transverse cervical rotation. So that's important for me to emphasize in this little micro lecture, that when you hear rotation in joint motions, it's more like a merry-go-round. And when you hear terms like flexion, extension, abduction, adduction, those kind of terms, it's going to be more like a swing. Okay? I hope this helps. I hope you guys are doing well. Stay safe.